All right, so we got states. So next is what's called the model or the transition model. Sometimes people refer to it as the transition function. And basically, it is a function of three variables. It's a state, an action, which I haven't defined for you yet, and another state. In fact, since I haven't defined what an action is for you yet, let's skip that and actually do define actions for you. So the third part of our model are actions. Actions are the things that you can do in a particular state. So what would the actions be in this world?
Well, the four different decisions I could make were the up, down, left, and right. Though it's maybe a little confusing because I think those were also the four possible outcomes.
That's true. Well, no, there were other outcomes. You could stay where you were.
Right.
Right. So these are actually the actions. These are the things that when I'm in a given state, I'm allowed to execute. I can either go up, go down, go left, or go right. You'll notice that, as I described before, there was no option not to move. But there could have been, and there could have been other actions like teleport, or there's anything that you can imagine. But the point is that your action set represents all of the things that the agent, the robot, the person, or whatever it is you're trying to model is allowed to do. Now, in its full generalized form, we tend to think of the set of actions that one can take as being a function of state, because there are some states you can do some things, and some states you can't do those things. But most of the time, people just treat it as a set of actions, and the actions that aren't allowable in a particular state simply have no effect. All right, so we understand states. They're the things that describe the world. We understand actions. Those are the things that you can do, the commands you can execute when you're in particular states. And what a model describes, what the transition model describes, is in some sense the rules of the game that you're playing. It's the physics of the world. So it's a function of three variables: a state, an action, and another state, which, by the way, could actually be the same state. And what this function produces is the probability that you will end up transitioning to state S prime, given that you were in state S and you took action A. Got it?
I think so. So the S prime is where you end up, and the SA is what you're given. So you plug these three in. Oh, I see, and you get a probability out. But the probabilities have to add up to 1 if you sum it up over all the S primes.
Right. That's exactly right. So, for example, if you think about the deterministic case where there was no noise, then this is a very simple model. If I'm in the state, the start state, and I take the action up, then what's the probability I end up in the state immediately above it?
Was that a 0.8?
No, when we first started in the deterministic world.
Oh, that was probability 1.
Right, and what would be the probability you ended up in the state to the right?
Probability 0.
Right. In fact, the probability that you end up in any of the other states is 0 in the deterministic world. Now, what about the case when we were in the non-deterministic world where an action would actually execute faithfully only 80% of the time? If I'm in the start state and I go up, what's the probability that I end up in the state above?
That was 0.8.
Right. What's the probability I end up in the state to the right?
That was 0.1.
And what's the probability I end up where I started?
That was also 0.1.
Right. And 0 everywhere else. And that's just sort of the way that it works. So the model really is an important thing. And the reason it's important is it really does describe the rules of the game. It tells you what will happen if you do something in a particular place. It captures everything that you know about the transition of the world, what you know about the rules. Got it?
Did you call it physics before?
I called it the physics of the world.
Huh.
These are the rules that don't change.
But they're very different from real-world physics.
Well, yeah, although they don't have to be. I mean, in some sense, you could argue that a Markov decision process, what we've described so far, these three things, in fact, do describe the universe. The states are, the positions of all the atoms, the positions and velocities of all the atoms in the universe. The transition models, as you do take certain actions in the world, whatever they are, how the state of the universe changes in response to that. And the actions are whatever those set of actions can be.
And it can be probabilistic or it's not probabilistic?
It can definitely be probabilistic. Transition models are, by their very definition, probabilistic.
Gotcha.